Okay, so today we're going to be talking about triangle congruence. And if you remember from yesterday, we talked about if triangles are going to be congruent, all their corresponding parts have to be the same, okay, the same shape as each other. And so, like, if you want to show that this triangle is congruent to this one right here, well, obviously they aren't because I didn't draw very well, but you have to show that this part is congruent to this. You've got to show that this part is congruent to this one, and then the bottom part is congruent to the other one right there. And then also the angles that are corresponding will match each other as well. I always talk to kids and say, it's kind of like if you want to prove that you have a twin all your corresponding parts have to match each other. So like your nose has to be the same, okay, as your friend's nose. If they're not exactly the same, well then they're not you're not going to be congruent. Your eyes have to be exactly the same shape and size. Okay, all your corresponding parts have to match or you're not going to look congruent to each other. Okay, that is quite a silly picture, but you can get the idea that um, every corresponding side and every corresponding angle has to match each other. Well, in the world of triangles, we we have learned, like in the last chapter, that the bigger the angle, the bigger the side across from it. Okay. And so if this angle matches this angle here, okay, probably the sides will be somewhat proportional. Okay. There's no guarantee that if they have the same angle that the triangles will be congruent, but if enough parts are matching, then actually we can do a shortcut and not have to show that all three angles and all three sides are the same as each other. Okay. So the shortcuts is what we're going to be learning today. Um, and so I'm going to teach you guys some agreed upon shortcuts to show, hey, two triangles will be congruent if these three parts match each other. Okay, and so it's on the front of this. So we'll begin this today, and we're going to take a couple days to work through it. But I just want to start teaching you that you don't have to prove six things to prove that two triangles are congruent. Okay, once you've shown the appropriate three things match between two triangles, then they will be congruent. Okay, so the definition of congruent triangles is one proof. We did that yesterday. That means that all the corresponding sides and all the corresponding angles are congruent. Okay, all three corresponding sides and all three corresponding angles are congruent between the two triangles. Okay, that's the most rigorous proof. Okay, we show six things match between two triangles and then we're good. But the problem is that's kind of tedious. And so because of the angle side relationship, okay, the bigger the angle, the bigger the side, they're related on triangles, okay? We know that the angle side of a triangle relates to the length of the side across from it. So we have some shortcuts, okay? There are some postulates and theorems below that we can use to help us show that two triangles are congruent to each other, okay? Because of that relationship. Another thing we should realize is that there's something called triangle rigidity. Okay, meaning if you've got a triangle with certain dimensions, you can rotate and reflect it, but it's not going to change the length of any sides. Okay. Um, and so if you've got something that is like 3 and 5 and 7, well, if you have something that's 7, 5, and 3, that'll be congruent to it. Okay, so it's just a rotation of the other one. So that's one of the reasons we talked about rotations and reflections is that you can rotate or reflect the same shape or translate it, and it's still this congruent to it's an isometric transformation. So if you know all three sides of a triangle and you have another triangle with the same three dimensions, they will be congruent to each other. And so that's the very first shortcut. Okay. If all three sides match the corresponding sides of another triangle, guess what? Their angles will match each other as well. Okay, they're not going to crush on themselves. If all three sides match all three sides of another triangle, those two triangles will be congruent to each other. Angles will also be congruent. We don't have to measure them to know that. They just will be. And so that is a really great shortcut proof is all three corresponding sides are congruent to the other ones. There's another one, it's called side angle side. Okay. Now, um, the thing is, like, if you got two sides, and you know the angle in between them, okay? It says included. Okay, if you're included in a little group hug, I'm standing right here with my arms out, like hugging on two people. It's a little silly and awkward in my kitchen. But the truth is, if you've got two sides and the angle between them that match the other two sides and the angle in between them, then the truth is those two triangles will be congruent. Why? Well, because if you have an angle in between the two sides that are congruent to the other two sides, then that angle impacts the length of the side across from it. And so, therefore, technically, all three sides will actually be congruent to each other, okay, in both triangles, because that angle impacts the length of the side across from it. Okay, so side, angle, side, two sides, and the angle in between those two sides will be a very good proof as well. Okay, because the measure of the angle between those two sides actually tells you that the length of the side across from that angle will match that other side. So side and then an angle, then a side that match another triangle with the same dimensions. Let's see, here we go. Side, angle, side. And then, so if all three sides match another triangle, those two triangles would be congruent. If two sides match, but then also the angle in between them also matches another triangle, then those two triangles have to be congruent to each other. Okay. Can you imagine, like, if you had this side and this side, but the angle was different, okay, well, then it wouldn't match, okay? So you have to have the same length as a triangle, and the angle in between them has to match. That will guarantee a matching triangle, a matching congruent triangle. So this one would not match if the angle was different, okay, in between those two sides. We do need to make sure you know what an included angle means. An included angle is the angle in between two sides, okay? So you take two adjacent sides, two sides right next to each other, and then A would be in the included between this side here and this side here, the one in between them, okay? If you're included in the group, you're inside the group, okay? So it's between those two sides, like a little sandwich, okay? So you can imagine a piece of bread, another piece of bread, and the angle is right in between those. It's kind of a wonky sandwich, but anyway. And because of the angle side relationships, we know that the length of a side is definitely based upon the measure of the angle across from it. Um, that's a fundamental thing that we're going to hold on to when we're talking about triangle proofs. Um, and then the next one would be angle side angle. If you know two angles and the included side in between them, then those two triangles will be the same. So two angles and the side in between the two angles that match. Why? Well, because this angle here will impact the side across from it. This angle here will impact the side across from it. So technically, we're talking about all the parts of the triangle. Okay, this side here impacts the angle across from it. So if you have these three things in a row, okay, two angles and the side in between them that match another triangle, those triangles have to be congruent to each other. Okay, so that's kind of a weird one for kids to picture. Um, and then another one would be angle, angle. Okay, if you got two angles and the side you know is after that. So you start at the two angles you know and you walk around the triangle, two angles and the side after it. Okay. Um, you could call it angle, angle, side. You could technically start at the side and then say, and then I know two angles after it. But you start at something you know and you walk around the triangle. Um, you can't skip things. Okay. So like you wouldn't go from like side, you don't know anything this way when you walk around a triangle. You know two angles and you know a side after it. Okay. So over here, we know two angles and we know the side in between them. Okay, so angle, side, angle. So it's a little weird. What do you know? And then you have to kind of go sequentially around the triangle, say, what do I know? And so if I know two angles and the side in between them, that'd be angle, side, angle. If you know two angles and then the side after it would be angle, angle, side. And so that will prove that two triangles are congruent. And then this last one is called hypotenuse leg. And that would be if you have a right triangle and you know the hypotenuse, which is across from the right angle and you know one of the legs. That will prove that two triangles are congruent to each other. So those are the shortcuts. And you're like, why would I want to know all those? Well, because the six proof way is kind of long. Okay. The definition of congruent triangles takes a long time because you have to prove six things. Okay. And I don't want to show six things. I'd rather know the shortcuts and say, if I know three important things that match another triangle, well, then the triangles will be congruent. So why is angle, angle, angle not on this list? Okay. Well, if you think about it, if three angles match on a triangle, like this matches this right here, and then this one matches this one right here, and then this one right here matches this one right here. Notice I'm drawing those angles. If you took out your protractor and measured them, especially if I drew them right, they could be dilations of each other. So say like this was 2 and then like 3 and then say 5, okay? This could be like a dilation, like times it by 3. So like this would be 6 and this would be 9 and this would be 15. So they're like proportional to each other, okay? But they're not going to be congruent because the angles being the same, it'd be like you having a Barbie doll fashioned after you, okay? Your angle should match, otherwise it won't look like you, but you're obviously not the same size and shape as your Barbie doll. And so you're proportional, okay? The triangles would be, and it would say similar. That means proportional. Okay, so similar doesn't mean like, oh, all the humans in our room look the same. No, we're talking about similar meaning in a very special way mathematically, a dilation of each other, dilating it bigger or smaller, but still your angles match, but your size probably does not. Okay, so you can imagine like at Macy's Day Parade, if they took a person and they're like, hey, let's do a dilation of this real person. Your angle should match, but you're obviously your size is not the same. They're not congruent. Okay. They're more proportional or similar to each other. So angle, angle, angle doesn't work. That's more of a similarity type thing rather than a congruency thing. Okay. And so what we're going to do in this chapter is I'm going to give you a picture. And the thing is, I'm going to ask you, will these be congruent to each other based on the visual evidence and the given markings on this diagram? You're like, well, how would I know? I mean, they all look the same as each other, but how do you know from the diagram? Okay, and so what you're going to do is you're going to look for things that you can get from a diagram. And the things that you can get from a diagram would be vertical angles and reflexive sides. Okay, and I'm trying to remember what else would be. We'll get into this. I'll look and say, is there anything else I need to remind you of? You can definitely notice linear pairs if that is a factor, but normally vertical angles and reflective sides are things that if you notice them in a diagram, you can assume they are true. Okay, so a reflexive side means normally we say when it's a reflexive side, we're like, a side is congruent to itself. You're like, well, that's dumb. Well, look at this. On this first diagram, okay, I'm trying to show that these two triangles are congruent. And the thing is that I know that this bottom is congruent to this bottom here. Okay, why? Because in the mark, okay? I also know that this right angle here matches this right angle. They're both 90 degrees, okay? And so I know two things. I have to know three, and they have to spell one of those acronyms on the first side. The reflexive side would be this right here. Do you see that this vertical, I can't talk. Okay. Do you see that this vertical segment here is part of this left triangle and it's also part of the right triangle, but it's also the same length, okay? Because it's really the same segment. So that would be an example of a segment that is a member of two triangles, but obviously it doesn't change shape or length when you look at one triangle versus the other because it's still the same length, okay? That's a reflexive side. And so if you've got a right triangle, you can look for the hypotenuse and the leg to match each other. The hypotenuses don't match, okay? What we have here is a side, okay, that matches another side. We have an angle, okay, and then we have another side. We have two sides and the angle between them. So these would be congruent. Why? Because of side matching an angle between them and another side. And so these two would be congruent, and the proof that we would use would be side angle side. Okay. The next diagram, you can notice that the first thing that we know would be an angle. These two angles match. We also know that there are two sides in the corresponding that match each other. And you're like, two is not enough. Okay. Do you see that there's a common side right here that is a member of both triangles? Okay. And even though it's a member of both triangles, it still retains the same length. Okay. This one, we know two sides, but we don't know an angle in between them. Okay. And so this is angle side side. Not a good word. Okay. Even if you do side side angle. And if you look back here, side side angle or angle side side is not on our list of okay things to say. Okay. Not just because it's a bad word, it doesn't prove it. It's called the ambiguous case. And so this would be not congruent. Okay. And because it is not a valid set of things that match each other. You can have three things that match each other in two triangles, but they have to be the appropriate things. And I can show you a visual diagram to say, hey, why doesn't this work? Okay. And it's not because it spells a bad word. Okay. The next one, I have this side that matches this side here. I have this side here that matches this here. So two sides. Three sides is a good proof, but we don't have that. But notice from the diagram, we can also mark reflexive sides and vertical angles. Do you see there's a vertical angle here and here? So this would be a side, and an included angle, an angle in between them. So there are side, angle, side that are congruent between the two triangles. And so they are congruent. Why? Because of sides, angle side. And then the last diagram, I know this side matches this side. I know this side here matches this side here, but we also have a common side, a reflexive side, meaning there's a side that is part of both triangles and it obviously retains the same length, even though it's in part of two triangles. So side, 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 we know they match the three sides of the other triangle. So these would be congruent by side, side, side. Okay. So the next thing we're going to talk about would be an actual proof. And notice there's no steps here, is it? Okay, so we're working on this. Okay, we're going to not do this very often by yourself, but I do want to build your creative logical sense. Okay, and so we're given that AC is parallel to BD. Okay, so we're going to draw those little triangles on there. Okay, and we're going to draw a little proof. Okay, that was a nice sound. Okay, here we go. And then what we're going to do is we're going to say also AC is congruent to BD. So this segment here is congruent to the segment right there. So we're going to start our proof with this. So AC is congruent to BD. Why? It's given. Okay. All right. So we have a side that matches a side. Woo-woo. Okay. The next thing we know is that you see that there's a reflexive side in between them. We're trying to show that the two triangles pictured are congruent. Okay, so we can also say that this segment here, BC, is congruent to itself. Okay, and this would be reflexive, if I could spell. Okay, reflexive property of congruence. So this is congruent to itself. Okay, so between the two triangles, we actually have two sides that match. Okay, we've got a side and a side. You can write side and side. So we got two sides that match each other. And then we're like, well, there's nothing left. Okay, we did both of these things right here. Okay. Oh, actually, we did one of these things. Okay. So the next thing we can say is they gave us that AC is parallel to BD. Okay, that is given. And anytime you have parallel lines, we have alternate interior angles. Okay, and so that's what we're going to be talking about now. Okay, and so let me zoom this in. Scooch it up so you guys can see what I'm doing. Oh, that's my alarm. Okay. Okay, so we are going to say that, do you notice that this angle here and this angle here are members like a common angle. They'd also be alternate interior angles. So if we say um, angle ACB and angle CBD are alternate interior angles. Okay, why? Definition of alternate interior. Okay, so we're calling them out. And because the lines are parallel and they're alternate interior angles, what must be true about those angles? Well, they have to be congruent. So angle ACB has to be congruent to angle CBD. Why? Alternate interior angles. Theorem. Okay, so we have a side, another side, and an angle in between them that are congruent between both triangles. So we can say step 6, triangle ACB is congruent to triangle DBC. Why? Not definition of congruent triangles, because we didn't prove all three things. It's going to say by side angle side congruency theorem. That's step 6. Okay, so we checked, we proved it. How did we show it? We showed that 3 corresponding parts match the 3 parts of another triangle, and it was part of our agreed upon shortcuts. Okay, so let's look at the next one. We want to prove that the 2 triangles shown are congruent. Okay, so like this triangle here is congruent to this one right here. That's what we want to show. Okay, and so what we're going to do is we're going to start with what do we know? And we're going to say, can we use one of our shortcuts to help us do that? So step 1, we're given that EF and GH are congruent. So we're going to just start with that. EF is congruent to GH, and that's given. Step 2, that EH is congruent to GF. Why? It's also given. So that would be this one right here is congruent to this one right here. Okay, so those 2 are congruent to each other, and it's given. It's a little hard to mark that, but we've got that. So we've got 2 sides that are congruent to each other. Now, the thing is this, they don't give us anything else. So what do we do? Well, look for vertical angles. There are vertical angles, but that's not going to help us, okay? The vertical angles here are not really even part of those 2 triangles, okay? They're not a vertex of those 3 triangles. Those are just the intersection of the 2 triangles. So that's not going to help us there. So let's get rid of those. So the other thing is we've got a common side at the bottom. Okay, do you see that it's a member of both triangles? And so that's that 3rd side. And so what we can say is side FH is congruent to itself. Why? We're not dumb. It's the reflexive property of congruence. And so as a result, we know that 3 of the sides of the first triangle match the other triangle. And so therefore, triangle EFH has to be congruent to triangle GHF. Why? Not triangle congruence no, because we didn't prove all the 6 things by the side congruence theorem. Okay, so look at this. We're looking for all these. I should write postulate because look at this. They are postulates. Okay, the angle side is a theorem, and the hypotenuse leg is a theorem, so we can write postulate. Okay, we can fix that. I'm not going to be real mean about that, obviously. Okay. Let's fix this postulate. Okay, there we go. Let's try another one. Okay, so B is the midpoint of DC. Okay, so a lot of times they won't give you a specific side, but they'll tell you a fact that allows you to claim that 2 parts match. Okay, so on this one right here, we're going to say step 1, B is the midpoint of DC. Why? It's given. And then as a result, if B is the midpoint of DC, well, we know these parts match. Why? Midpoint theorem. Okay, so we're going to say DB has to be congruent to BC, midpoint theorem. Okay, so that would be great. We use this one and we used it for our good to say, hey, those two parts are matched. Okay, step 3, we've got that AB is going to be perpendicular to DC. Why? It's given. We should number this 1, 2, and 3. Okay. Now, if you have a right angle, then what degree is formed? Okay. If you have a right angle, then there's a 90-degree angle that is formed there. Okay. And so how do you do this right here? You would say, um, that means that this part's a right angle and that's a right angle, and they're going to be congruent to each other. Okay. And so we could kind of jump to, there's levels of formality of proofs. But one thing we could do is we could say angle ABD is going to be congruent to angle ABC. Why? Oh, no, let's not jump there. Let's be a little bit more formal. Hang on. Rewind yourself. Angle ABD and angle ABC are right angles. Okay, so let's actually state things. Okay, so definition of perpendicular lines. So if you've got perpendicular, you know they form 90-degree angles. They form right angles. And so therefore, we can now say angle ABD is congruent to angle ABC. Why? Right angle theorem. What's the right angle theorems tell us? If you've got a right angle, guess what? It's congruent to all the other right angles. They're all the same, congruent to each other. So we've got a side that matches another side. We've got an angle, okay? And then do we know anything else? We don't know the hypotenuse, okay? So we're not going to do hypotenuse leg, but we do know there's a reflexive side in the middle, okay? So AB, I'm going to go up here for 6. So AB is congruent to AB. Why? Reflexive. Property of congruence. And then we know that step 7 is triangle ABD is congruent to triangle. I don't know why there's not a triangle here. ABC. Why? Because we showed that there are two sides and an angle between them. Okay, there's two sides and the angle is between them. So here's a side, here's another side, and the angle we know is in between them. So side, angle, side. And then congruence, and that is going to be postulate. Okay, so if that is congruent between two triangles, we know the two triangles have to be congruent to each other. All right, I think that we are going to have time for about one more here. Okay, let's see. This next one. This next one says, given the angle 1 and 4 are congruent, okay? And so all these are congruent, and then 2 and 3 are congruent to each other. So I'm going to mark that 2 is congruent to 3, okay? Okay, that is given. Okay. And what we're trying to prove is that NOP and ANUM are congruent to each other. So NOP and ANUM. So NOP, where is NOP? NOP. So this bottom, my voice sounds great. Sorry. NOP and ANUM are congruent to each other. So that bottom right triangle, or it looks like a right triangle, and also the top triangle here. Okay, so the bottom triangle, the top, we're trying to show that those two are congruent to each other. Okay, so in that bottom triangle, we're trying to say, what do I know that matches? Okay, and so we have angle 2 matches angle 3. So number 2 and number 3 are an angle. Excuse me. And then 1 and 4 are not actually parts of those triangles. Okay, they're kind of a piece of it, but it's not the most helpful. So the question is, what is going to help us to prove that those two triangles are congruent to each other? And they're going to walk us through on this thing, okay? So they're gonna go through some formal steps here. Okay, this is kind of a big old proof. Okay, so if we know that 1 and 4 are congruent, well, we also know that the measure of angle 1 and 4 are equal. Okay, so that'd be the definition of congruent triangle or congruent angles. Okay. Okay, so notice this goes to here. So that means definition of congruent angles. And so same with this goes to here, definition of congruent angles. Okay. And then because we can only add numbers together, we can't add angles. Okay, so the angle addition posture only works if you're talking about their measures. You can add measures, you can't add shapes. Okay, so if you add up these two equations here, this one here plus this one right here, on the left side, you'll notice angle 1 and 2 become here. And then on the right side, you'll see they go here. So this would be angle addition postulate. Okay. Oh, this is addition, sorry. Um, property of equality. Okay, you're allowed to add two equations together. You do that with elimination. You can add two equations together. So if we add these two together, we get this one right here. You add this one right here, you get that there. So then they're saying, well, look at the picture. Okay, in your picture, if you add up 1 and 2, you get this entire angle. Okay, and so what they're trying to say is angle N basically. And so we're going to say angle, not N because there's a couple there. We would just call it M N O will be equal to, okay, we're going to do this in a couple steps. Sorry. Um, we're going to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle N. Okay. And then we could say the measure of angle 3 plus the measure of angle 4 equals the measure of angle O. So like plus these up, you get the measure of angle N up there. Okay. We could call it more formally a different angle, MNO, but the overall angle O is what we're talking about. Okay. Just for brevity. Okay. Not the most formal proof, but we're trying to talk about what we're doing here. Um, and then we can do the transitive property to say, hey, do you see that in step 3, the measure of angle 1 and 2 technically are the measure of angle N. So measure of angle N is equal to the measure of angle O. Okay, so we're saying that um, this equals N. I'll get a different color. Okay, so that's going to go on this side here. And then we also have the measure of angle O. And so that's going to go here. And so they'll be equal to each other. Okay. And if they're equal, then their measures, okay, then their angles will be congruent. So angle N has to be congruent to angle O. Again, we're not doing the best. We're talking about angle N, the whole thing, and angle O. So the good news is at this point, we've got two angles that are going to be congruent to each other. We've got in this bottom triangle, okay, we've got this angle being congruent to that top angle. We also have angle 2, okay, who is going to be congruent to its corresponding one in the top one as well. Okay, so we've got, and it's a little bit tricky to see, but we've got this angle here, and we've got this angle here. We've got two angles. So we've got an angle and an angle. The last thing we're going to talk about would be we got NM is congruent to, oh, that's our cat. Good morning, sweetheart. Okay. NM and OP are congruent to each other. Okay. And that is given. NM and OP. Okay. And so that's a side. We got a lot of things that are congruent to each other. And then we also have this side right here that's congruent to itself. Okay. That's a reflexive. Okay. And then Based on, I guess we're gonna not use that angle up there. Let's talk about, we've got a side, an angle, and a side that match the side, the angle, and the side of the other. Technically, we got more than that. There's also an angle that we've shown that matches it, and it was part of the given, but we've got a side angle side that matches. Um, Honestly, talking with my other friend teachers, if you just write side angle side or side angle side congruency, that's plenty at this point. Okay. And so we're going to ignore this angle here. We're going to say we've got side, okay, that reflexive side here. And we're trying to show that this triangle here is congruent to the top. Okay. And so we've shown that this angle here matches the top angle here. We have shown that that side on the left, okay, matches itself, okay? And then we've also shown that the top and the bottom are the same as each other. So side angle side is what we've shown is congruent to each other. Okay, I'm going to hold off on showing this one right here. If we have time tomorrow, we will do that. All right, well, thank you so much. I hope you have a great day.